Hello, in today's video we're going to be continuing section 8.5 on using intercept form. Some of these topics are going to feel like I am covering them again as repeats from our first video, and they will be, but we are going to be introducing a few new concepts from our last video. So example 2, continuing from our last video, is to graph the function shown. Since we are talking about using intercept form, I am going to graph this by using intercept form. You might also be able to use vertex form here if you see that this -8 means that we are just going to shift our parabola down 8 units, and then the 2 is going to change our pattern. However, since we're talking vertex form, I'm going to go ahead, intercept form, I'm going to go ahead and factor this to use intercept form. So I factor out my 2 to get x squared minus 4, and now from here I do see that this x squared minus 4 is the difference of squares, so I can write that as x plus 2 and x minus 2. All I did is I saw that as x squared minus 2 squared, so I take the x and the 2, I add them, and I subtract them. And then I still have that coefficient, that a value of 2 on the front. So solving for my zeros, if I want to know where this equals 0, well, that's going to be where each of the factors is equal to 0. So that means x plus 2 is equal to 0, or x minus 2 is equal to 0. So this function has a 0 at -2 and also at +2. So I'm going to place both of these on my graph. I've got a 0 at -2 and +2. Which tells me that my vertex must be exactly in between those two x-intercepts. So to find the exact x value of my vertex, I simply add the two values, so -2 plus 2, and then I divide them in half. So 0 over 2 is 0, tells me that my x value of that vertex is 0. So to find the exact point, I plug in that 0. 2 times 0 squared minus 8 is a -8, meaning my vertex is at the point 0, -8. So we knew that it was on this line, and then by plugging that value in, we found out that it is here. So I now can sketch my parabola by connecting those 3 points the best I can. All right, your turn. Pause the video and try out this one on your own. I'm going to go ahead and start by factoring. I factor out a 4 and I'm left with x squared minus 9. And again, this is the difference of squares, so I can factor the x squared minus 9 as x plus 3, x minus 3, and then that 4 remains on the front. To find the zeros, I let h of x be 0. So I have zeros at -3. And I also have a 0 at +3. So I can go ahead and put those points on my graph. I have 0 at -3, 1 at +3, and so I know that my vertex must be exactly in between those two because parabolas are symmetric. So my vertex I can find by saying that x has to be right in the middle of my zeros. So I add the zeros, -3 and 3, and divide by 2. And sure enough, just like I drew my line, that x value is 0. So then to find the exact place where the y value is, I then plug that 0 in. So 4 times 0 squared minus 36. And I find out that my vertex is at 0, -36, which is way beyond my graph. So my vertex would be somewhere way down there, and my graph is going to look something like this. Except clearly much nicer looking. Let's try again. No, not much better. But your parabola would be upward facing, and it would have a vertex of 0, -36. Example 4, we'd like to talk about finding the zeros of each function. So finding the zeros just means where does y equal 0. So I put a 0 in for my y value or my f of x, and then I solve. Now in this case, we do need to factor. So I'm going to start by taking out my GCF of -2. If possible, we want to make sure that that leading coefficient is positive. So I took out the negative with the 2. And then I factor that x squared plus 5x plus 6. So x squared, the two factors of 6 that multiply to 6 and add to 5. 1 and 6 are not what I'm looking for. 2 and 3, this is what I'm looking for. So x squared plus 2x plus 3x plus 6. And factoring by grouping, I see that x plus 2 is repeated. So I've got x plus 2, x minus 3. So in factored form, I've got negative 2 times x plus 2, x plus 3. So that tells me that x could either be a negative 2 or x could be a negative 3. So my zeros are negative 2 and negative 3, meaning that this is where my graph crosses the x-axis. All right, your turn. Pause the video and try finding the zeros for g of x. So again, I'm factoring and solving for when g of x is 0. So I take out my GCF of 3. And then I factor that quadratic. I need the two factors of 4 that multiply to 4 and add to negative 4. So I want two negative numbers. Negative 1 and negative 4 give me negative 5, but negative 2 and negative 2 do give me the negative 4 that I want. So x squared minus 2x minus 2x plus 4. And factoring by grouping, I've got x minus 2 times x minus 2, or x minus 2 squared. So in factored form, I've got 3 times x minus 2 squared, which means that the 0 occurs where x is positive 2. And you may remember briefly in the past we have talked about multiplicity. This 0 shows up 2 times, so x equals 2 with a multiplicity of 2. So there is only one 0, it is at 2, but it does have a multiplicity of 2. Or it occurs in 2 factors. Now we're going to combine the process that we've used here with our first example from this video and graph using zeros. The only difference here from the first one is that we are now dealing with a trinomial instead of a binomial, but the process is going to be very similar. So use zeros. I'm going to go ahead and let h of x be 0 because I want to know where y equals 0. And then I factor. Factoring, I will have x minus 3 times x plus 1, which tells me that x could either be 3 or negative 1. So I've got a 0 at negative 1, and I have a 0 at positive 3. So my vertex must be somewhere in the middle. So my vertex, I'm simply going to add those two zeros and divide by 2. 2 over 2 is 1, which means my vertex occurs at 1. So my vertex is going to be on this line right in between those two zeros. To find exactly where, I plug in that value. 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 is negative 4. So that tells me that my vertex occurs at 1, negative 4. So that would be right here. And that's enough for me to be able to sketch my graph. So your parabola would look something like that. All right, your turn. Go ahead and pause the video and practice graphing these two parabolas on your own. In f of x, I'm going to have two zeros, one of 1, and 1 is positive 4. So I'm going to go ahead and put these on my graph. I've got positive 1 and positive 4. So that tells me that my vertex is somewhere in the middle. So to find that vertex, x is going to be equal to, I add those two values and divide by 2, and I get 5 halves. So plugging that value in, f of 5 over 2 is 5 over 2 minus 1 times 5 over 2 minus 4. So that's 3 over 2 multiplied by negative 3 over 2, which is negative 9 over 2. So my vertex lies at 5 over 2, which is approximately, or which is 2.5, and it is on the y value of negative 9 over 2, or negative 4.5. So my vertex is going to be here on that axis of symmetry. And sketching my parabola, it will look like that. Last, I'm going to start by factoring, so g of x is equal to x plus 4 times x minus 3, which tells me that my zeros are at negative 4 and positive 3. So I've got a 0 at negative 4 and 1 at positive 3. So my vertex has an x value that is negative 4 plus 3 over 2, or negative 1/2. So to find exactly where that vertex lies, I plug in my negative 1/2. I have a positive 1/4 minus 1/2 minus 12. So that gives me a negative 1/2 minus 12, which is negative 12.5, or negative 25 over 2, which is off my graph. So I do know that it is somewhere down here, giving me an upward facing parabola that looks something like this. That brings us to the end of part 2 of graphing parabolas in intercept form. Thanks so much for watching, and have a great rest of your day.